Okay, so on Wednesday we started our 10-1 notes, arcs, and sectors. So we named the parts of the circle, right?
Yeah.
We, yes, Tony?
You gave me the wrong notes.
So we reviewed that there are 360 degrees in a total circle. The equation of the circumference of a circle is 2 times pi times the radius. Okay, 2 radii equals what? So here's a radius, and here's a radius. What does the whole thing equal? Diameter. So this 2 times r, I also could write it as pi d. What's d stand for? Diameter. So we won't use pi diameter very often, but r times 2 is diameter, because diameter equals 2r. Okay? I will tell you, I'm one of those weird people that if I'm given the diameter, I'll divide it in half and multiply by 2, because that's just a creature of habit. Okay, so we use the fact that an arc length or a sector was a proportion, like a fraction of the circumference, yes? And the central angle was a fraction of 360. So we set it up and found that the sector length is s, we use that variable, is theta, which is the central angle, times 2 pi r over 360. So where'd 2 pi r come from? The circumference. And 360 came from the total circle. So we have the fraction of the circle, the theta to the 360 degrees, times the circumference. So we're never going to have to find this again, but we need to know that formula. Yes? And we did the first few examples using that. So today we are going to go on. Today we are going to go on and do area. So, a sector of a circle is the region bounded by 2 radii and the intercepted arc. So what it is, a sector is here, 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 and here. So this circle is divided up into 4 sectors. Yes?
Yeah.
Could I combine 2 sectors and make it 1? Yes. Could I combine 3 sectors and make it 1? Yeah. Somebody's like, can you combine all? Sure. If you combine all, you have a circle. Yes? Okay. So a sector is a portion of a circle. It's a fraction of a circle. So just like when we did arc length, it was our fraction of our theta to 360 times their circumference. We're going to do area equals theta over 360. Well, if we're talking about the area, we probably need to put the what formula? Oops, that's the wrong line. What's the area of a circle, guys? You remember? Pi r squared. So you should know that. So now let's do area of a sector, sorry. So again, we just use A. And we're using our theta over 360 because that gives us our fraction of the circle, right? Mm-hmm. And when we're doing sector length, it's part of the circumference. But when we're talking about area, we're talking about area. So we use pi r squared. So you need to use this. So I showed you how we could have used diameter in the last one, but we can't use diameter in this one, can we? Because 2 times r is different than r squared, isn't it? Unless r is 2. Okay, so what is the area of the sector? So I have 2 sectors here, but since I only have an angle for one of them, we're talking about which one? This one over here, right? So our formula is area equals theta times pi times r squared over 360. So what's theta?
165.
165 pi and r squared. So what's r?
3.
3 squared is
9.
9 over 360. Now there is a degree here and a degree here, so those degrees reduce out, and this is no longer an angle, it is a measurement. So if there's something behind your 3, you need to use it. I know 9 goes into 36, yes? So I get 40. Does something go into 40 and 165? At least 5, right?
Oh, yeah.
So 5 goes into 48. 5 goes into 16 3 times, carry 1, so 33. So 33 is 3 and 11, yes? Does 3 or 11 go into 8? Nope. So I have 33 pi over 8. Now, with sector length, I told you make sure you put them if there's a unit of measurement there. But if area, even if there's not, you need to put a u squared. Because with area, we always have square units. Okay? Unit squared. So if they don't give me feet, inches, miles, meters, whatever, we still have to put a u squared, okay? Now, do you guys know mathematically why we have square units when we have area? Last time somebody's like, because it's area. Well, yes, because it's area, but there's a mathematical reason. So if I had 3 inches times 3 inches, yes? I would have 3 inches. 3 times 3 is what? 9. And what's inch times inch? Inch squared. So mathematically, that's why it is a square unit. Okay, so you try this one on your own. You too, are you working on it?
I'm trying.
Okay, did you get 259 pi over 18 unit squared?
Yeah.
Okay, you should have your setup should be 59 pi times 100. Where did I get 100? 10 times 10. So I took a 0 out of 100 and a 0 out of 360. And then I had 10 and 36, which both reduce by 2, don't they? So I get 5 and 18. So I have to take 5 times 59, which is 295. And then pi just comes along for the ride over 18 units squared. So you only have 4 problems today. And you got the area and the arc length. We have one more page of notes. We got to do them. Okay? But the area and arc length are what you guys need today. Okay, on our notes, the last page of notes, you have a word bank at the top. Up here, you have arc length, major arc, sector of a circle, arc measure, minor arc, segment of a circle, central angle, radian, and semicircle. We haven't talked about a radian yet. Okay, and segment of a circle we haven't talked about, but everything else you should know. So I want you, make sure you're with the pencil because you might be wrong. I want you to try to fill in the boxes. So I'm going to give you just like a minute or so. By process of elimination, you should be able to get them. Guys think you have enough to start? Okay, Regan, what do you think number 1 is?
Semicircle?
Yep, semicircle. Dakota, what about number 2?
Central angle.
Well, only this is shaded in. Anybody else? Yes. It is a sector of a circle. Because that might change other things, right? We're going to skip 3. Okay, what do you think 4 is? Central angle. Anybody want to go for 5? Nope, not. What? It is arc measure because the length would be on the outside, the measure is on the inside. So you're close. And we don't use arc measure very often. We'd probably say central angle. Okay. So 6. Major arc. How'd you know it was a major arc?
Because it's a lot bigger than 7.
Yep, it's a lot bigger than what's left. And it is bigger than 7, and 7 would be what?
Minor.
Minor arc. Okay. Now what's 8? Yep. And what was the variable we used for arc length? Oops. What's the variable because we don't write arc length, what do we write? What's the variable? S. Because sometimes we say sector length. Okay? You'll probably hear me say sector length more than arc length. It means the same thing. So let's write sector length underneath it. That just means the arc right here, doesn't it? Okay. So now we have 3 and 9. So what are the 2 words we have left?
Radian and segment of a circle.
Okay, we have radian and segment of a circle. Which do you think 9 is? Segment of a circle. And these are just ones we're not going to do a whole lot with. And this line right here that I'm highlighting, it is called a secant line. And a secant line is any line that intersects an object twice. Okay? So that makes a segment of the circle. But it's not a sector because a sector has the central angle in it, doesn't it? So that's just a segment of a circle. Okay, now that makes this be a radian up here. And I'm going to explain what a radian is, but I'm not going to hold you much responsible for it, but I want to let you know what a radian is, okay? So if you notice, I have R right here. What does that mean, this R? What, Noah?
What's the radius?
It's the radius, yes? But I also have R out here. Well, if I have the same R, that means this length and this length are equal, doesn't it? Yeah. So what a radian is if you take the measure of the radius of a circle and you had a piece of string and you measured it and you laid it on the circumference of the circle, that is 1 radian. Okay? So a radian is the radius laid on the circumference of the circle. Every circle has approximately 6.28 radians. So 6.28 of its radius could be cut out of the circumference. Where do you think that number 6.28 comes from? Pi. Isn't that half a pi? 3.14? Yeah. So I'm going to draw this line right here. And I'm going to say this is 0 radian. And so if I go to here, it's pi radian. And if I keep going, a pi plus a pi is what? 2 pi's, or approximately 6.28. Now, every circle, guys, no matter how big or small. So this circle right here, if I took the radius and measured it, I'd approximately get how many? 6.28. This circle right here on the end of my pen, if I measured the radius and then laid it on the circumference of this little circle, I would get approximately what? 6.28. The big circle in the center of the basketball court, guess what? It'd be approximately 6.28. Any circle, no matter how big or small the circle is, 1 radian is approximately the same proportion on every circle. So you'd have 6.28 radius. So 6 and almost a third radius you'd cut out of the circumference. Isn't that kind of neat? I always thought that was weird that this little circle and that big circle have almost exactly the same number radian just because your radius changes sizes, right? Okay, so this right here was just to get you some words. I wanted you to introduce you to radian. We're not going to work with it. Segment kind of makes sense, but we're really not going to work with a lot. But you still need to know what those things are, okay? So you have 4 problems today. I expect you to get busy and get them turned in before you leave, because they should not take you long. And you have 12 minutes.